In this video, we are going to learn about quadratic function. We're going to learn about the parts of the parabola and a vertex form. So let's try to check and remember how we will solve the vertex of each function. For example, we have function f of x equals to x minus 2 squared plus 3. So we have the vertical shift and we have the horizontal shifting. Go back to the functions. So therefore, we will have now coordinate of positive 2 and positive 3. How about the other one? So here, the f of x, the 2, is the shrink or the opening of the parabola. So we have now x plus 2 squared minus 4. Minus 4 is the shifting of the vertical. And then horizontal shift is inside of the function. So therefore, we will have now as negative, we have 1 and negative 4. Give the domain and range of the following function. So remember that the domain is the value of x and the range is the value of y. So therefore, we have the domain is 2, 0, 2, and 4. The range are 4, 6, 8, and 10. Okay, so the objectives of our lesson discussion this video is to define, identify, and graph quadratic functions. We have to identify and use maximums and minimum of quadratic function to solve problems. So we have to define the axis of symmetry, what is the standard form, minimum value, and the maximum value. So quadratic functions is in the form of f of x is equals to ax squared plus bx plus c. And then the standard form for vertex is f of x is equals to a times x minus h squared plus k. And we have to graph the parabola, and then all are symmetric to a line called the axis of symmetry or the line of symmetry, LOS. So when you transform quadratic function in the previous lesson, so back in graphing functions, so you have to show, or we can see that what will happen to the function if it is negative and a positive function. So we have function f of x, x squared. So we all know that the origin is in 0, 0, or the line LOS now is the value of y, okay, the line of symmetry. And then this shows that the parabola is symmetry curves. The axis of symmetry is the line through the vertex of the parabola that divides the two parabola into two equal parts. So therefore, back here, so that the line will divide the two we have graphs in equal parts of parabola. So therefore, here we have the line of symmetry which is in 0. So the axis of symmetry is the vertical line through the vertex of the functions or graph. So the quadratic function f of x is equals to ax minus h squared plus k has axis symmetry, x is equals to h. So therefore, the value of x, okay? So which is the h and k. So identify the axis of symmetry for the graph of f of x, negative 1/2, x plus 5 squared minus 8. So what is the shifting here? So we have negative 8 and negative 5. And then we have the negative function. So therefore, the graph is open downward, right? So therefore, because h is equals to negative 5, so the axis of symmetry is the vertical line, x is equals to 5. So therefore, the axis of symmetry now, they will divide into 2. And then that part is in negative 5. So analyze the graph on the graphing calculator, or if you are using graphing calculator, you can go directly and then you can check the parabolic or the parabola, and then you can check where is x equals negative 5. So therefore, when you're going to solve for that one, because it's x negative 5 and it's go down by 8, right? Go back to the equation. So we have negative 1/2 times x plus 5 squared minus 8. So negative 8, the vertical, we have shifting, horizontal shift. So shift, negative 5 and negative 8. That's the reason why we have now the graph is here. So therefore, the graph is here, and then open downward because the function is negative. Now, identify the axis of symmetry for the graph of f of x is equals to x minus 3 squared plus 1. Okay, vertical shifting plus 1, horizontal shifting negative 3, which is equals to positive 3. So therefore, this is now equal to 3 and 1. So we write the function to find the value of h. So we can have now x minus h, right? H, which is the line of symmetry or LOS. So therefore, we will have now equals to h equals to 3. So the axis of symmetry is the vertical line x equals to 3. So when you're going to graph that, so therefore you will have this function. Okay, let's go. Another useful form of writing this quadratic function is the standard form. The quadratic form of a quadratic formula or a quadratic function is f of x is equals to ax squared plus bx plus c, where a is not equal to 0. Okay, so the coefficients a, b, and c can show properties of the graph of the function. You can determine these properties by expanding the vertex form, which is now into the function of a times x minus h squared plus we have k. So this is the vertex form, this is the standard form. So we can have now as f of x a times x squared. So we expand this one, distribute, and then simplify into the equation. Simplify that one, distribute. So we can have now as ax squared plus bx plus c. Okay, therefore this one is our function. A is equals to a in the standard form is the same as the vertex. As in vertex form, it indicates whether a reflection or vertical stretch or compression has been applied. So the a there is the opening of the parabola. If it is positive, upward. If it is, we have negative, downward. And also it also reflects. Okay, so the vertical stretch or compression has been applied there as well. So if it is smaller, it will vertical stretch, or we have the parabola open wider, or it will just we have shrink. Okay, so we have the shrink and then the stretch. So b is equals to negative 2h. Solving for h gives h equals b minus 2a, or equal to negative b over 2a. Therefore, the axis of symmetry is x is equals to n. For quadratic function in the standard form, x equals to negative b over 2a. Okay, so this is how you will find the h. And then c, notice that the value c is the same value given by the vertex form of f when x is equals to 0. So f equals to 0 is equals to, we have ah squared plus k. Okay, so c is the y-intercept. Okay, so therefore you can find now in the form of the slope-intercept form, right? So we have y is equals to mx plus b, which is the b there is the y-intercept. Okay, so what are the properties of parabola? So we have opens upward if a is greater than 0, but if a is less than 0, that will go downward, right? So the axis of symmetry again, so x is equals to negative b over 2a. The vertex is in the point of negative b over 2a, and f function of negative b over 2a. And the y-intercept is the c. Okay, so this is the thing that you need to remember. Okay, so consider the function f of x 2x squared minus 4x plus, we have 5. Determine whether the graph opens upward or downward. So looking at the graph here, we can see already that this one is positive. So if it is positive, it is upward. So find the axis of symmetry. So because a is positive, so therefore the parabola opens upward. So the axis of symmetry is given by x equals to negative b over 2a. So therefore you will have negative b is here, right? A, b, and c. ax squared plus bx plus c, right? So therefore the axis of symmetry now is in the line x equals to 1. Okay, so when you're going to solve for that, so we have x is equals to negative b over 2. 2a. So find the vertex. So the vertex now is the value of, we have the vertex lies on the axis of symmetry. So we have the 1, the other one is 1. So you have to substitute the function 1 now into the equation so that you can find the value of y, right? So how to find the x and y intercept, right? So you have to let x equal 0 and y not equal to 0. But here we have the f of x is, the x coordinate is in 1. So therefore you let the function into 1 so that we can have the vertex into the 1 and positive 3. Find the y-intercept. So y-intercept is to let x equals 0. So therefore we have 5. So graph the function now. So when you're going to graph the function, graph by sketching the axis of the symmetry and then plotting the vertex and the intercept point 0 and 5. Use the axis of symmetry to find another point on the parabola. Notice that 0, 5 is 1 unit left of the axis of symmetry. The point of the parabola symmetrical to 0, 5 is 1 unit to the right of the axis at 2 and 5. So therefore you have now here. So therefore you will get as, we have 1 and 3, right? 1 and 3. And then how to find, we have the x and y intercept. So you can check that one. So here, the 5 there is here, right? It will intercept into 5. So if you want to find all the values of x, so you can check with that one in your table. So next one, determine, we have example number 2, consider the function. We have f of x is equals to negative x squared minus 2x plus 3. So here it's negative, so therefore that is downward. Find the axis of symmetry. So x is equals to negative b over 2a. So therefore the axis of symmetry now is equals to negative 1. And then to find the vertex, so we have let f of x is equals to negative 1. So therefore you can have now negative 1 and positive 4. Y-intercept is equals to 3. Okay, so that is how you will solve for that one, right? So the c value is the y-intercept. How to find the vertex? Find first the axis of symmetry. So the axis of symmetry is negative 1. So therefore you will have now here, go back to the vertex. So therefore we get negative 1 and positive 4. And then the intercept is 3. So when you're going to graph that, okay, so negative 1 here, and then we have 3, right? So and then it will, negative 1 and 4. So it will go open, we have downward because it is negative. And then it will crosses to, we have y is 3. To find these 2 here, so you can just let the value of x, okay? So just estimate that one. You're just sketching the graph. So for the function, determine whether the graphs open upward or downward. Find the axis of symmetry, find the vertex, then we have find the y-intercept and graph the function. So here opens downward, right? Negative. And then we have axis of symmetry, so we'll have x equals to negative b over 2a. Therefore the axis is negative 1. So the vertex, the same function, whatever you get in the axis of symmetry, you just put that one in the function, and then there is no value of c here, so therefore the y-intercept is equal to 0. And what will be the graph now? So the graph of the function, so we have here, okay, go back here, so we will have now open downward, and then there will be 2 values, so therefore it will shrink, okay? So therefore you will have now, as we have the axis of symmetry is here, negative 1, the LOS, okay, the line of LOS, okay, line of symmetry, and then we have this function over here. The vertex is, we have negative 1, and what is our vertex again? So go back to the equation. So we have the vertex is, we have negative 1 and positive 2. Then the function will crosses to 0. Now, let's try to find the minimum and maximum values of the parabola. So when a parabola opens upward, so the y value of the vertex is the minimum value. Okay, so therefore here. And then when the parabola opens downward, the y of the vertex is the maximum value. Therefore, the domain is all real numbers. Okay, the range is all the values greater than or equal to the minimum value. The domain is all real numbers because all the values of x, right, from negative infinity going to positive infinity. But the range is all the values less than or equal to the minimum value. So from here going down, but from the minimum, if the parabola opens upward, so minimum value going up, right? All the values of that one are the range. But here going down, the value of the range. Okay, so upward minimum, downward is maximum. So the minimum or maximum value is the y value at the vertex. It is not the ordered pair that represent the vertex. Okay, so always remember, it is not the ordered pair that represent the vertex. It's only the y value, okay, the vertex. So find the minimum or maximum value of the function f of x, or f of x is equals to negative 3x squared plus 2x minus 4. Then state the domain and range of the function. So from here, it will open downward. It's negative, right? So therefore, it will goes to, we have down. So a is negative, the graph opens downward. So how to find the vertex? So first thing you will do is find the vertex, which is x equals to negative b over 2a. So we get now 1 over 3. So then find the y value of the vertex f negative b over 2a. So we get now 1 over 3, okay, equals to negative 11 over 3. So what is the maximum value now? The maximum value is negative 11 over 3. So the domain is all real numbers and the range is all real numbers less than or equal to, we have negative 11 over 3. So the graph of that, so it will going down. Okay, so therefore that is the graph of the function. Next, find the minimum or maximum value of the equation. So therefore this one opens upward, okay, because it is positive. Then state the domain and range. So upward, and then we have to find the vertex. So x is equals to negative b over 2a, so we get 3. And then to find we have the vertex, okay, so therefore we will function negative b over 2a, so therefore we get now 3, so we get 6. So we have now the minimum value is negative 6, the domain is all real numbers r, and then the range is from, we have negative 6, okay, so numbers greater than or equal to negative 6, because this one will open upward. Okay, so the vertex is, what is our vertex again? The vertex is 3 and we have negative 6. So therefore your graph now is here. So again, how to find the minimum and maximum? So if it is open upward, okay, open upward, you can find the minimum value. And then if it is, we have maximum value, so it will go downward. So it is positive, this one is negative. So if you want to practice more, try to find some examples and exercises in our textbook of Algebra 2, which is the Algebra and Trigonometric with Analytic Geometry. So you can try to solve some problems over there. For your classwork, so I will be posting that one in we have Google Classroom. If you have questions and clarification, don't hesitate to email and comment. Thank you so much and have a nice day.